Okay, and so now I'm gonna plot this data to look and see what it looks like, look and see what canopy height is like across time at this site. And in order to do that, the first thing that I need to do is I need to, I'm gonna use the raw date column to get my time information. So I wanna plot, if I wanna plot canopy height over time, I need time on the x-axis of my plot, and I'm gonna use the raw date. So there's a bunch of different date columns and time columns. I'm gonna use this raw date column, but this isn't quite in the right format. This isn't quite in the right format for plotting, and so I need to first use this library called Bluebirddate to change that raw date column into a better format. So I'm gonna go ahead and just overwrite the canopy height data frame. I'm gonna use this function called mutate, which is from dplyr, to add a new column to my canopy height data frame with the correctly formatted date. So I'm gonna call that column formatted date. It's a good description of what it is. And then use from Bluebirddate this function ymd hms. And then run that function on the raw date column. So what that does, ymd hms from Bluebirddate takes the date information in the raw date column and converts it into a format that's more usable. It's more readable for our plotting. So when I run that, you should hopefully see that you have a new column called formatted date. Okay, and now I'm going to plot, and I think this is the last different R library that I'm going to be using. Sorry if it seems like a lot of different ones, but these are all really useful R packages. I'm going to use ggplot2, which is an R package for plotting. I'm going to read in ggplot2. And then this argument from ggplot2, which is ggplot, is used to set up the axes and the data source for a plot. And so I want to specify that I want my data to come from the canopy height data frame. And then I want to specify that using AES, which stands for aesthetics, I want to specify that my x-axis should come from that formatted date column in my data frame. And then I want my y-axis to be from that mean column. Remember, the mean column has the value of the trait observations. In this case, all of the mean values are the canopy heights. And then the second thing you have to specify with ggplot is what type of plot you want. So now we have set up what our x and y axes are and where the data is coming from. And I'm going to use this function geom_point, which specifies that I want my plot to be a scatter plot. So when I run that, it should plot canopy height across time for season 6, which is from 2017, I think. So yeah, we can see, as you'd expect, throughout the course of the year, throughout the course of the year, canopy height is increasing because the plants are growing, which is about what you'd expect. Okay. And then so this here we just plotted all of the trait data for one of our possible traits. We can also go back to the original season 4 data frame if we want to create this same plot, but for all of the different traits that are in this data frame, we can do that pretty quickly using ggplot. So I'll set up my plot in the same way using the ggplot function, but this time I'm going to get my data from that season 4 data frame. And then I'm again going to plot on the x-axis the formatted date. And which we didn't do. So I don't have a formatted date column yet, so I need to make a formatted date column in my season 4, which is the same as what I did up here for my canopy height data frame. I'm going to do this for season 4. So I'm going to use that mutate function from dplyr, create a formatted date column, using the Bluebirddate function to convert my raw date into a more usable date. Now that I have my formatted date column, I'm going to plot formatted date on the x-axis, and then the mean value, which is the trait observation value on the y-axis. And then I'm going to use geoPoint to specify that I want it to be a scatter plot again. But now I want to create one plot per each type of trait that's in the trait column. And so I'm going to use this function from ggplot called facet wrap to do that. So I'm going to say is I want to, for each of the unique sets of rows for each of the trait types, I want to create a plot like this plot right here. So I will specify the column that I want that to come from, is traits. And then I'm also going to use this additional argument for facet wrap called scales. And I'm going to set that equal to free_y. And the reason that I'm doing that is so that the y-axes, depending on the values of that trait, will vary. So they don't all have to have the same y-axis. So I'm going to run that, and it'll take a minute just because it's kind of a lot of data. And so now we have that same plot of trait across time. Oops, put that over here. The same plot of trait across time, but now it's for all of the traits that are in that season 4 data frame. So you can see a bunch of those things here, like NPQ, a bunch of other traits that were measured, absorbance at different wavelengths. Okay. And so that is how you pull down trait data from the TERRA REF project using that traits package.